Hi, everyone, and welcome. We're excited that you could join us today for Bob Ward's session, Getting Started with Performance Monitoring in Azure SQL. This past marathon features back-to-back live webinars delivered by expert speakers from the past community. The sessions will be recorded and posted online after the event. You will receive an email letting you know when the recordings become available. My name is Ree Irish. I'm a Senior Program Manager for Microsoft, where I serve as the program lead for MVP in the SQL community. I'm also an organizer, a frequent speaker, and co-leader of the past Women in Technology virtual group. I have a few introductory slides before I hand everything over to Bob. If you require technical assistance during today's webinar, please use the question pane located on the right side of your screen and someone will assist you. This is also where you may ask any questions throughout the presentation. Please feel free to enter your questions at any time. Anna Hoffman and Elaine, I'm going to say it wrong, Dormail, who are program managers with the Azure SQL team with Microsoft, will be monitoring the chat. They will also read those questions aloud to Bob, and we'll try to save some time for questions at the end as well. Please note that there will be a short evaluation at the end of the session, which will pop up after the session ends in your web browser. Your feedback is really important to us for future events, so please take a moment to complete this. Thank you to our presenting sponsor, HVR. And keep learning all year long. Visit pass.org and discover the free educational resources available to past members. Connect, share, and learn. This session is presented by Bob Ward. Bob is a principal architect for the Microsoft Azure Data SQL Server team, which owns the development for all SQL Server versions. Bob has worked for Microsoft for 26+ years on every version of SQL Server shipped, from OS2 1.1 to SQL Server 2019, including Azure SQL. And I will not take up any more of your time. I will turn everything over to Bob, so you're good to go.
Gosh, Ree, thank you so much. Really appreciate you coming online today to help us moderate our session. Thanks especially to the PASS organization for putting this together. Interesting times we're all in, so virtual webinars like this can become very important for people to continue their education and learning. And a very special thanks to my colleagues, Elaine and Anna, who are here to take your questions throughout this whole session. You know, what I kind of envision today is making this pretty interactive, and in the sense that I'll be presenting these different topics on Azure SQL monitoring, and I've asked Elaine and Anna to take your questions throughout the entire session. So I'll pause a little bit as we go along to make sure we've caught up, but they won't actually be reading these out loud. They'll be answering questions in the question window, but you'll get to see the questions and their responses. So instead of us having to put all the questions at the very end, we'll certainly leave a couple minutes for that though. I hope and encourage you to ask your questions throughout the presentation today, and they'll be online, you know, to try to address all those questions that you have. And as Ree said, if there are technical issues, her and others will be on the question window to answer those kind of problems as well. Now, when I do a lot of presentations, everybody wants to know, you know, at the very end, how do I get this stuff? How do I get the deck that you just presented? Now look at this screen right here. If you go to ak.ms/bobwardms, this is a OneDrive folder where this deck I'm presenting is already out there. So you could look at it right now, or you can look on it later on, and you can get all the information that I'm presenting today available as soon as we're done here. And if you'd like to get some hands-on exercises in using Azure SQL and SQL Server in general, you can go to ak.ms SQL Workshops, which is a free training by our SQL engineering team. It's a GitHub site and has all sorts of great hands-on exercises for you to use. And here's some other information about my contact. I love talking to people, so you can follow me on Twitter, or you can contact me at my email address, especially if we get done today and there was something very specific in mind that you did not get information about, specifically about Azure SQL performance monitoring. I don't mind. I love interacting with people all the time. It doesn't mean I can turn around an email response in minutes, but I do love talking to people about our technologies. So again, thanks for joining today, and let's kind of dive into today's information. You know, the PASS organization reached out to me not long ago and said, Bob, we're doing a PASS marathon on performance monitoring, and you've been around in the industry a lot, been along with SQL Server for a long period of time. You know, maybe you'd like to come present to the PASS community and to our overall SQL community. And I said, yeah, I'd love to do that. And I presented on the topic of SQL Server performance monitoring in many different aspects throughout my career at Microsoft. But lately I've been spending time working with Anna and Elaine. They specialize in the Azure SQL space, and I've been spending a little bit of time with them trying to lend my expertise with SQL Server and comparing that to Azure SQL. You know, using the 26 years of SQL Server experience and my perspective on SQL, what does it look like for Azure SQL? And specifically today, that's what I'd like to do in terms of questions you might have about Azure SQL, specifically related to performance monitoring, and how does that compare to SQL Server today? You know, are there tools and features the same? Do I need to get retrained? Are there new scenarios that I need to be worried about? Is things the same? Are things like dynamic management views the same in the Azure SQL space like I've used for years in SQL Server? So those are the kind of type things I'd like to talk about today and show you, do some demonstrations as well. And at the very end, we'll talk about some of our partners that we use today and that we know and love that do monitoring for SQL Server and how they work with Azure SQL. And then I got a special little small demo at the very end to talk about some futures that Elaine and the team that he works with are kind of looking at in terms of new ways of doing monitoring for the Azure SQL space. So I hope you're going to enjoy today. We're going to go through some terms about Azure SQL first, so we're all on the same page. Because you know what? Quite frankly, that term Azure SQL is new to a lot of people. They've heard Azure, they've heard of Azure SQL Database, they've heard of Managed Instance, they've heard of Virtual Machine, but they're not quite sure how they compare together. So first of all, if you think about using Azure Virtual Machine with SQL Server, just think about these basics. Number one, Azure is going to manage the host and the hardware. You, though, are going to manage the virtual machine itself. You're going to deploy a virtual machine just like you do with Hyper-V or VMware today, but you're going to deploy that within our Azure infrastructure and our data centers. And so you're going to be responsible for everything in it, the whole entire guest OS itself, whether it's Windows, Linux, and SQL Server, you're going to manage that whole thing. However, because you're running in the Azure data center and infrastructure, there are value added services that we can provide to you. Specifically also, if you register your virtual machine with us and tell us you're running SQL Server, we can do things like automated backups and automated security patches and things of that nature. But you're also going to see, from a perspective of performance monitoring, we're going to snap into the Azure infrastructure and provide you some unique performance monitoring perspectives outside the VM that work within, say, the Azure portal. And we'll show you what that kind of looks like a little bit later. Now, it could be that you don't want to manage the entire virtual machine. You love the fact that Azure manages the host and the hardware, but you'd like the feel of a SQL Server. Like, you don't want to worry about the VM anymore. You just like the feel of the entire SQL Server surface area, a SQL instance with multiple databases, and you're going to manage all of that. But you've heard of PaaS, Platform as a Service, so you'd like to take advantage of some of those kind of type things. So for example, if you could deploy an Azure Managed Instance, we can provide you built-in high availability and offer extra security services as part of using a managed instance. And also, we're going to snap into that Azure infrastructure from a performance monitoring point of view and provide you value add there. But a lot of the things you know and love in SQL Server from performance monitoring perspective are going to be available to you in a managed instance. Now, it could be that you really don't care about an entire SQL instance. You really just want to worry about a database. So let Azure manage the host, the hardware, the VM, the SQL Server. You just want a database. You still want the feel of SQL Server, though. You'd like to, for example, just use Management Studio against this thing and run DMV queries, and you can do those kind of things. But more and more, the concept you're thinking about is that I'd like to look at a database perspective what I'm doing, and I really want to take advantage of Platform as a Service services. I want intelligent performance. I want security. I want high availability. I want all those things to Azure to manage for me so I can focus more on my application at a database. So when you think about the word Azure SQL and that term and that branding, think of these three elements and these three choices that we're providing you in the cloud. But the common theme across this is SQL Server, the SQL Server engine powering everything you see here, and the common tools and interfaces that you know of, Management Studio, T-SQL, those kind of things, all working in this space. Now, from a performance perspective, just to give you a feel to make sure we're all on the same page about what we're capable of, you have choices when you deploy these three things to ensure you get the best performance. So for a virtual machine, just like you might do in your own data center and pick certain aspects of a VM, how many CPUs you get, how much memory you give a VM, what kind of storage do you give it, you do the same thing in Azure. We call that a size. You're going to pick certain sizes of VMs to deploy your SQL Server. You can choose a SQL Server and operating system combination for what we call the marketplace or gallery, or you can do it yourself. You can deploy Windows, for example, using the gallery and Azure Virtual Machine, and then you can go ahead and just install SQL Server within that. You're going to see, and you can read about it in our documentation, about the concept of a resource provider for Azure Virtual Machine. And if you deploy SQL yourself, we highly recommend you use that, because it allows us to take advantage of those value-added services for things like automated security updates and so forth. Now, for a managed instance, you're going to have some different terminology when you start deploying this thing. You're going to have a choice. You're going to say, I'd like a general purpose managed instance, or like a business critical managed instance. And within that, you're going to pick what we call compute hardware choices, like the number of virtual cores and the maximum amount of data I want in my databases for my managed instance. Now, business critical has some interesting aspects. Not only is it going to give you some better high availability choices, but from a performance perspective, you're actually going to get a little faster storage to go to that kind of type model. And even in managed instance, because some of the lowest vCores we provide in the way we deploy this managed instance for you is like 4, you might want bigger density. You might more managed instance to be deployed when you're what's called your virtual cluster. So we have something called a managed instance pool, which is in preview right now, and allows you for smaller vCore choices, pre-populated deployments to make things faster, and higher density of managed instances. So keep that in mind as you're looking at these choices. You're going to make decisions on how to deploy things to get maximum performance. And we're going to show you an example of what that looks like in a couple of demos. And then finally, for databases, you have lots of choices. First of all, from a kind of what we call a pricing tier perspective, you can choose what we call a database transaction unit-based system, which is either basic, standard, or premium choices. So you're going to pick what's called a DTU capacity, a number, which is a performance number for you and storage. Or you can use the vCore model like you did with managed instance and pick something called a general purpose or business critical tier. You in addition have something called a hyperscale tier, which is our new option that we've provided as a deployment choice, which gives you maximum performance and scale and size within an Azure database. Now, if you choose to use general purpose, you actually have a couple of different choices you didn't have with managed instance. One's called a provision choice, which is a standard fixed vCore and storage, or something new called serverless. Serverless allows for dynamic scaling and the ability to pause and idle a workload to give you better choices to pay for compute and storage. And then finally, if you want to group together a bunch of databases, we offer this concept called Elastic Pool. And all of those choices except for hyperscale are available for Elastic Pool. So I want to make sure you just understand the ground foundation of your choices to deploy Azure SQL. This is all just SQL servers behind the scenes powering all of this, but you can pick different choices to give you certain performance options. This beyond the scope of our talk today. We probably should come back and do an availability talk as well for Azure SQL. Some of these choices are going to dictate your high availability and SLA options, but we're not going to go into that today. Let's just kind of give you a ground foundation of knowledge of terminology, because you're going to see some of that today when I talk about performance monitoring for both managed instance, VM, and for databases. Okay, so a couple of things about interfaces for Azure SQL, because of some people I've talked to are a little bit confused about what's possible, not possible. Well, first of all, we have something called the Azure Portal. You may have seen that today. It's a web browser. You may not have known the fact that the Azure Portal can also be deployed from a Windows application that's in preview today, or even from a mobile application on your phone. And then the standard tools you're used to using, like Management Studio and our new Azure Data Studio, also work and interface just nicely with the different choices I just talked about for Azure SQL. And then from a programming perspective, of course, the T-SQL language is still king and paramount and works across our different Azure SQL choices. But you may have not have known that PowerShell commandlets are built specifically to interact with Azure SQL databases and managed instances and VMs. The Az CLI, which is cross-platform across Windows, Mac OS, and Linux, also can be used to manage and interact with Azure SQL deployments. And then finally, those two options are powered behind the scenes by a REST API. So if you would like to go natively to the REST API directly itself, we've got all that documented for how you manage Azure SQL deployments using REST. Az CLI and PowerShell behind the scenes are going to use those REST APIs as foundations to interact with Azure SQL. Okay, with that foundation in mind, let's go into some capabilities and performance monitoring. So when I was looking at Azure SQL and SQL Server, and I was talking to some customers about this, they didn't even realize the fact that these capabilities from a performance perspective exist in Azure SQL. Like, for example, did you know for Azure SQL Database and Managed Instance, you get the full power of column store, online and resumable indexes, emerald TP, and even partitions. Now, you don't specify files and file groups with partitions, but you still get to specify the fact that you have partitioned databases and take advantage of partition concepts within Azure Database. And then what about like TempDB files? TempDB files are something that's a common configuration choice for customers. But for example, for the Azure SQL Database, as you pick different vCore models, we scale up and auto-configure the number of files for you automatically. So we do some things that are smart behind the scenes to kind of help maybe optimize your performance. And then intelligent query processing, which is a new functionality you may have heard me talk about in SQL Server 2019. We actually started that in cloud. So Azure Database is kind of where we started all that functionality that as you move to a database compat level, we get faster with no app changes. And then from a capacity perspective, and notice I put a point here, these keep evolving. I was just evolving. I was just looking at our documentation about like what is possible with Azure SQL today. Well, you can get VMs up to 400 plus vCPUs and even 6 terabytes of RAM, or even databases with things like hyperscale up to 128 vCores. Excuse me, not hyperscale, but in our new generation choices, you get up to 128 vCores and with hyperscale 100 terabytes of database size. So if you thought that maybe Azure SQL did not have capacities from a compute and storage for your needs today from a database perspective, they actually do. And I expect these numbers and these choices and capacities just to keep evolving and getting larger and larger as we move on the journey with Azure SQL. Now, from a performance monitoring perspective, these are probably the things you're used to if you're a SQL Server person. If you're a Windows, you're used to using Windows Performance Monitor. If you're in Linux, you're probably using something called Grafana. But look at the heart of the engine of performance monitoring, things like dynamic management views, extended events, the query store, or query plan debugging with show plan options, or things like lightweight query profiling and some of those kind of type features. And they're used to using Management Studio to look at query store reports or to run queries for dynamic management views and using PowerShell. So if you think about all of that functionality as a basis for how you do performance monitoring today, let's use this as our base to compare to Azure SQL. What's the same? What's different? What's different in the Azure infrastructure to match some of these things? And then what's value add? What's new that the cloud provides you that is not possible on premises today, or would cause you to build a lot of work yourself to make that possible on premises? Let's start there from that foundation. So first of all, as you start looking at virtual machines, managed instance, and database, you'll notice that except for virtual machine, you don't have access to a lot of the operating system type of information you're used to seeing, things like performance monitor metrics and so forth. So within the Azure infrastructure itself, Azure provides its services. And in the case of the term service, I'm talking about a virtual machine that you deploy, a database, or a managed instance. So for us as developers building these cloud services, Azure provides a system for us called Azure Monitor. Azure Monitor behind the scenes being a metric and logging system available to services like database, managed instances, and virtual machines. And so we take advantage of that. And you're going to see some examples of how you're going to look at those metrics today in the Azure portal. So first of all, metrics itself, this built-in system for services, is kind of like a near real-time time series database. Whereas from behind the scenes, by default, if a service snaps into this metric system, you're going to have metrics kept around for like 90 days worth of history. And logging is a way we're going to be able to extend that. But imagine you having performance monitor, for example, built in, kept around for 90 days just because of the fact you deployed a virtual machine. And in fact, Azure metrics are resource specific. So virtual machines, for example, are going to be able to publish guest operating system performance counter information through metrics. Whereas an Azure database is going to be able to expose its built-in metrics for, say, CPU or IO and so forth through this metric system. The way you're going to interact with this monitor data is you're going to do something called Metrics Explorer. And you're going to see in the Azure portal, you're not going to see the term Metrics Explorer. You're going to see me show in the portal how are you going to use that Metrics Explorer interface to look at charting for things that you see in metrics. There's also a monitor API. So if you actually at a programming level wanted to consume some things going on for these metrics, you can actually use an API. Now, if you need to extend the lifetime of these metrics, there's a very rich logging system. And metrics are typically just normally value and numbers, but logging can go beyond that. And another ability of interesting aspect of using the logging system as part of Azure Monitor is you can have, including metrics, other log information sent to something called Log Analytics or Azure Storage or even Event Hub streaming. And we're going to see an example near the end where we're going to show you kind of the future of using log analytics for richer insights for Azure monitoring for things like metrics. So you got metrics that just come built in with these things. You have the logging system, which you can actually use to extend the lifetime of what's in these metrics, say to Azure Storage or Log Analytics. And then you have other capabilities from the Azure Monitor system. Number one, there's an alerting system. So you can set up alerts for certain performance monitor metrics that are coming for your Azure resource to do emails or text messages, or something can be consumed from an alert from an API perspective if a certain threshold is met for something important to your Azure resource. And then you're going to see when we start looking at this logging system, there's going to be a query language, something called the Custo query language, or KQL we call it. And the Custo query language is something you're going to be able to use against logs to query data inside this logging system. And we'll show a couple of examples of what that look like. So it's important you know this foundation, because the Azure Monitor, you're going to see a visualization of this through different aspects of VM and Azure Database today. So let's talk about virtual machine. If you're going to go down this concept of deploying SQL Server in a virtual machine, everything you're used today in VMware or Hyper-V works as it does in SQL Server inside the VM itself. So the guest OS, you're going to RDP into this OS, or you're going to do a secure shell into Linux, and anything you're used to using today, you get to see that inside the VM itself. But Azure Monitor is going to be plugged in with the virtual machine to perform and provide metrics, alerts, and logs outside the concept of going inside that virtual machine. So when you go through the process of deploying a virtual machine, you're going to have the ability to enable something called Azure Monitor for virtual machines. You can do it when you deploy the virtual machine itself, or you can do it after the fact through the portal or through APIs. And with that, you're going to get something called Monitor Insights, which I'm going to show you is kind of like a perfmon chart looking thing of looking at VMs. You're going to see guest OS metrics. You're going to get to see things like things you normally see in Windows Performance Monitor. You're even going to get some SQL Server Performance Monitor counters from that perspective. And you're going to get logging. You're going to be able to go through and run these Custo queries against these logs. In addition, there are a couple of things that I will not show you today that you can take advantage of for virtual machines, and that are some performance diagnostics and health checks based on data collected from Azure Monitor for virtual machines. So without further ado, let's stop and let's actually see a demonstration of this. Let me flip over and show you, first of all, in my Azure portal. This is my account for my Azure portal, and I've provisioned a virtual machine running Windows Server 2019 Data Center. And this is my size. Remember, I told you before you're going to pick a size. I've got something that has 4 vCPUs and 28 gig of memory. And there's other details behind what DS12v2 means, which you can look up in the documentation for as far as like IOPS provisions and how many data disks and so forth that you get in your system. What I'd like to do for this VM is show an RDP into the VM of what it looks like. This is very similar to what you'd see in your own server or a VM you've got SQL Server deployed. And in this particular VM, I've got perfmon already launched, Windows perfmon, and I'm monitoring processor time and batch requests per second. Now, what I'd like to do is kind of kick off a workload here, and then we'll talk about the results and what I'm seeing in the workload. So I'm going to go run this here. And this workload is going to use a popular tool you may have seen called OStress. So if you go look at the workload here from my script, I'm running OStress, I'm running AT version, I'm running 100 users, and I'm doing it a bunch of times with no results being consumed, just so I can go consume CPU. That's what I really want to do. I want to run a bunch of SQL queries against my SQL Server in my VM and generate a lot of CPU utilization. Of course, AT version is not going to do anything but just generate CPU. So if you go and look at perfmon, you're going to see, in fact, that's exactly what I'm doing. I've got 100% processor time, and I've got, I don't know, 35,000 or so batch requests per second, all running inside the guest OS itself. So I could even go into something like Task Manager, pull this up, and this is what you're used to seeing. I'm pegging all CPUs in this machine, really doing nothing more than that. But the reason I wanted to show this to you is I wanted to go flip back over and get a perspective and show you what does it kind of look like from this Azure Monitor perspective. So let's go back over here and let's scroll down and see here in the overview, you can see already, because I've enabled Azure Monitor for virtual machines, I already have some built-in metrics for the guest OS itself showing in my overview pane here. And if I'd like, I could go over here and look at a history by default. Remember, for metrics, we're going to keep it like 90 days worth. So I could even go back to see 30 days worth of history on anything going on for this VM. or I could go look at the last 6 hours if I wanted to. In fact, you can see here earlier, I was generating some CPU utilization on this VM to kind of test out this functionality I'm going to show you. But let's scroll down and look at Metrics Explorer. This is kind of a view of Metrics Explorer, but if I click on over here where it says Metrics, I'm literally looking at the Metrics Explorer API. And so the way I'm going to do this is I'm going to build some charts. So I'm going to pick guest here, and then I'm going to pick processor time from my metrics. So let me scroll down here and pick total processor time. And notice here, it is starting to show some CPU utilization, just as I saw in Perfmon. But what I want to do is I want to, just for the purposes of this demo, change my time range. I'm going to do the last 30 minutes. I'm going to pick it every 1 minute to show my granularity. And sure enough, there's my 100% CPU I was seeing inside Perfmon. Let me look at batch requests per second by adding another chart here. And I'm going to pick same thing guest, and I'm going to pick this time batch requests per second. You see the SQL Server Perfmon counters are showing up. So I'll pick batch requests per second. And sure enough, you can see here that my numbers are showing similar to the data. So I can see both charts at the same time here and see both numbers showing just like I saw in my guest. So one of the things I love about kind of seeing these charts is I get to kind of zoom in, even though I'm last 30 minutes. So I can take my mouse here, I can kind of scroll over, and it automatically zooms in at a higher granularity to what I was showing you earlier. See, I'm just kind of zooming in on a now minute interval there. And both charts automatically did that kind of zooming in. So let me go back and change this to an hour, or to automatically here, and do the last 7 days. Hit that, and all of a sudden now, boom, I'm looking at a historical view of the same type of data I was showing you in the chart. Now, what about the logging capability I mentioned? So if I go over and click on logs, I'm now looking at the built-in metrics, except it's stored into a log format. Now, I could have added more into this log, but I'm going to show you what this Custo query language example looks like. Now, I've actually predefined some queries here. There's all sorts of information we have here for you to be able to get started on Custo, because it's a very rich query language. But I'm going to run this saved query, which is going to show you an example of the syntax. Here is a Custo query for a perf object with where clauses, averages, and even the ability to render this into a chart. And you can see here, I'm showing you data for the chart of my CPU utilization. And if I wanted to, I could go back and I could change this. This was the last 24 hours. I could make this the last 30 minutes. I could run it again. And now it's going to render and show you what's happened here in the last 30 minutes. There's a lot of capabilities in logging. You can see all the different types of events, some of them not even related to performance, that I have the ability to run Custo queries against my logs. The last thing I want to show you was that insights concept. I mentioned the fact that Azure Monitor for Virtual Machines, we enable this, you get something called insights. This is going to feel very interesting, like a series of Perfmon charts. So when I click performance, I'm going to get now logical disk performance by certain drives I have in my system. So I can start measuring things like my delay in transfers. I can look at IOPS if I'd like to for my various drives. In fact, in this case, the F and G drive are for my SQL Server databases. But also notice I have a nice little chart here for utilization on CPU, and even for memory, IOPS, disk megabytes per second, and even disk latency. So, you get this idea here now that insights give you kind of a more richer way of looking at that Azure Monitor for virtual machines performance data. So this is just giving you an idea. Go inside your VM, use all the stuff for SQL Server you're used to using, but also outside the VM itself, the Azure Monitor system bolts into the virtual machine for SQL and provides you a rich integrated experience. Okay, so let me prep myself for the next one I'm going to show you. Let me go back to the deck now. And let's just pick up from here. So we just talked about VM. Let's give you a little bit of an overview of performance monitoring for managed instance and database. I'll show you some more demos in the portal, and then we'll do a little deeper dive. So first of all, remember what managed instance is. Let's just be clear about this. This is a SQL Server instance that when you start looking at it, feels just like a SQL Server, but you're not looking at the VM anymore. You're just worried about the SQL instance and the databases that go with it. So because it's a SQL instance, we need to give you all those tools and functionality you're used to using with a SQL Server. So pretty much all the engine tools and features from a Perfmon point of view, performance monitoring, are there. And in fact, there's a couple of extra things that we're going to add to you, including Azure Monitor metrics and logs for a managed instance. Now, a couple of things you should know. There's going to be some new dynamic management views that we're going to talk about in a second that are available to you for a managed instance, specifically around resource usage. That's going to be important for you because you don't have the access to like Windows Perfmon, for example. There's going to be some Azure specific extended events that we've added for managed instances that you can use as well. And the query store, which is a very important tool you'll use to do performance monitoring, it's on by default. You can turn it off if you want, but when you deploy a managed instance and deploy a database, we're going to turn on query store. And if you've not heard of lightweight query profiling, it's a functionality we've had for a while, but we turned it on by default in SQL 19, and therefore it's on by default in Azure Managed Instance for any database in the system. And it's going to give you that ability to go in and look at a query in flight and look at the plan operators at the operator level to see where's the progress of my query in flight from a row perspective specifically. So you can see, is my query 10% done? Is it scanning too much data? So lightweight query profiling, and you would interact with that through a series of DMVs, just like you would with SQL Server today. For an Azure database, it's very, very similar, but a little bit different. And so we do provide instance level diagnostics for you for a SQL Server perspective because each Azure database is deployed on its own SQL instance. But it's probably better for you to think of database scoped monitoring because you're really focused more on what's going on for your database. And many of the engine tools and features work just like SQL Server, not all. And so what do we mean by that? So for example, for dynamic management views, you don't get all of the management views that you get with SQL Server or managed instance. You get a subset, and you actually get a few new ones that are important to Azure. But I will just tell you that the common ones you need and love are there. Same thing for extended events. The common things you need to do performance monitoring for a database are going to be available for you. Things like query store, lightweight query profiling, those are on by default. And then there's some additional new things, which we're going to show you in a little bit deeper dive here in a second. You're getting some new visualizations in the portal for things like the query store. And you're actually going to get something called automatic tuning, which I'll describe here in more detail to show you what does that mean? What do we mean by the word automatic tuning? And then you're going to get a richer set of metrics, alerts, and logs for Azure Database through the Azure Monitor system than what you would have, say, for managed instance. So this is kind of the overview of what you're going to be using from an Azure Database performance monitoring perspective. And you just stop for a second and look at this list and compare that to SQL Server. Just keep in your mind, if you think Azure SQL Database doesn't have what you need, think of DMVs, extended events, query store. That kind of functionality is all there for you to use as you need to do performance scenarios. So let's stop for a second, go back to the portal again, and kind of show you what do we mean by that? What is some of the stuff we mean that's different and the same? Okay, so let me go back over into the portal. And I've got here an Azure database I've deployed. So first of all, I just want to show you, without getting to kind of a demonstration of it, that the same metrics and logs are available. So when you go to metrics, you have the ability over here to pick specific metrics dealing with your Azure database, like CPU percentage or IO percentage or space used, those kind of type things. In addition, the same thing for logging, you have Custo queries available to you to look at things from a logging perspective for things like metrics. So that's available. In addition, one thing I did not show you originally was alerts. So you have this alerting system. The alerting system allows you to go in here and build an alert rule based on a condition like, say, CPU percentage, and build something called an action group. And a group can be a series of members, subscriptions within Azure that allows you to send out alerts via text messages or emails or other ways through APIs for people to see when certain thresholds are met about certain performance conditions in your Azure database. So let me show you a little example of what I meant by performance visualizations in Azure and automatic tuning. I'm going to go back to my dashboard and pick on a different database called Workload Insights. So if you scroll down here on the left-hand side, these are various options for you to navigate your database. You'll notice here's something called Query Performance Insights. So if I click on this, Query Performance Insights is a visualization in the Azure portal running on top of the query store that is already automatically enabled by default for your database. And if you look here, by default, we're showing you kind of like a stacked chart of performance. Like, what are my most resource consuming queries in a stacked chart format in my system? In fact, let me kind of move this here so you can get a better look at it. And if I scroll down here, these colors are going to represent certain queries by query ID stored in the query store. So I'm going to see which ones consume, for example, if I want the most CPU percentage and even by execution count. I can look on things like CPU, data IO, and log IO, because remember, all that information is stored in the query store. So if I look at this model and I scroll down and look at a specific query ID, I can go in and see the query text, and then I can get details of history of the utilization of that query over time. In fact, if you've ever looked at Query Store, things are stored in terms of what are called runtime intervals. So this is showing me what is the performance of this query across the various runtime intervals over time for this database. Now, if you go back to Query Performance Insights, you'll notice at the top over here something called Improved Database Performance Database Advisors Recommendations. If we click on this, this is where we're going to start talking in terms of this idea of automatic tuning. And let me stop and explain what I mean. In SQL Server 2017, we introduced a concept called automatic tuning with something called auto plan correction. Auto plan correction was the concept of, if you had Query Store turned on, we could look at query plans that regressed over time and give you recommendations to say, hey, a given query had a different query plan that showed up and performance got really bad. You had the ability to turn on automatic plan correction for the SQL Server to auto force back a query plan that was better at a point in time. And that functionality exists in Azure SQL as well. But what we decided to do is to provide more than that. In Azure SQL, we're going to use a combination of the query store plus some information from dynamic management views. We're going to use machine learning algorithms to run services behind the scenes in the cloud, not to look at your data, but to look at the performance of your queries and give you recommendations. And these recommendations can be in the form of index suggestions or parameterized query suggestions. And even it can be in terms of dropping index suggestions that may have already been created. So in this particular view here, and by the way, this view can also be seen with a dynamic management view, not just the portal. You can see that there are suggestions for index creations and drop of indexes, and then some examples of when indexes were dropped or created in the past. Now, these are just recommendations, and you can get that by default. If you'd like, you can automate the functionality of this. And that automation exists at different levels. Notice this is the force plan automation recommendation. This was the auto plan correction option. The create and drop index options exist as well. And you have the ability, Azure has defaults, which is basically off for everyone, automation's off, or you can set this at what's called the logical database server level. So all databases pick up your options. So you inherit from a server, or you can pick and choose and do this per database. So you have all sorts of different options. If you were to go in and say, hey, I want to do create index on as an option, we would behind the scenes go back and look at these recommendations, and then we would auto create indexes for you. Now you may be thinking to yourself, okay, well that's not great if these indexes aren't good. So we wouldn't recommend an index if we didn't think over a period of time it was good for your workload, because we won't just make a suggestion based on a single execution of a query, but maybe on a series of queries. So once we do that, we're going to monitor performance and if necessary, drop indexes as well if we think that index wasn't good. So really that's the overall view of automatic tuning. It includes the ability of combining that auto plan correction with other aspects I talked about right here with recommending indexes and parameterization of queries or even automating those queries. So just a couple of views of what it looks like for Azure Database. I got one more demo I'm going to show you in a second here where we're going to use a real life scaling scenario to see what it looks like overall performance. So let me go back to the deck and we will do a little bit more of a deep dive here. So for managed instance, all your DMVs are available, or there's going to be a couple of new DMVs you might want to look at. One's called Server Resource Stats, which is going to give you more resource usage for CPU IO and especially log IO across your managed instance. In addition, you may want to know at a programming level, what choices did I make? How many vCores did I pick? What are my limits? Like what's my log rate limit? What are all the different things I might want to concern myself about? And there's a DMV called DM User DB Resource Governance you can look at as well. And that'll show you kind of from a T-SQL point of view, what are some of the things that I picked in the portal and what implicitly might I be limited on based on those choices. For extended events, all your objects are available. There are some new objects specific to Azure. For example, the overall usage of storage on your instance is available to go monitor from an extended event. And What's important for you to understand is that all your targets are there for extended events, but when you do a file target, since you don't have a local disk drive with a managed instance you have access to, just like you would in your SQL Server, you're going to use Azure Blob Storage. We've got great documentation and even wizards in the Management Studio tool to help you set up a file target through Azure Blob Storage to store your extended event data. And then for monitor metrics, you have logging in this particular case. So the resource usage that you would see in resource stats, data from query store are available at the instance or database level to use with logs to do custo queries against that type of information. Now for a database, there's a lot of differences here, and I won't go over every detail, but you certainly can go back and review some of these details a little bit later in our deck. Number one, most of your common DMVs are there, including things like DMOS performance counters. So if you didn't think you had access to SQL Server performance counters, you do. You do have access to that through that DMV. Things like DMDB resource stats or resource stats and logical master are going to be very important. I'm going to show you a demo in a second of how you're going to monitor your overall CPU usage of your database on your instance, or your IO usage, or even your worker limits and things of that nature. And then for Elastic pools, we have a resource stats version that's specific to Elastic Pool as well. And then the same DMV for governance for you to find out what kind of limits you have based on the choices you made for general purpose, business critical, serverless, all those type of things. This DMV can be used to look at those limits. But if you've seen me present before, like you want to geek out, if you really want to dive into the details, you'll have access to other DMVs that you can look at offline. Those are all documented to get a lot more interesting information about how we're doing resource governance behind the scenes for your Azure database. For extended events, all the common events you need are there. The common events, action, and targets, and again, for file target, you'll use Azure Blob Storage. For query performance insights, you can do a visual of the query store in the portal. That's what I just showed you here, is looking at query store. And then for monitors and metrics, we do have metrics. Managed Instance had logs. We do have the metrics capabilities for basic performance scenarios. And then we have Azure Monitor logging for custo queries for a wide variety of other metrics for your database. And then for automatic tuning, again, you can look at recommendations in the portal. There's DMVs for you to look at. And then the automation itself that you want to see about the tuning history we had is also available in the portal or through DMVs. And then for hyperscale, there's some very specific diagnostics that you may need to take a look at. And in our documentation, we have specific DMVs for you to look at hyperscale that are needed because of the unique architecture that it provides. So let's do another demonstration. I hope you've enjoyed kind of seeing these demos, because it kind of makes things feel a little bit real to you. So I've got a database here. I'm showing you my portal. And when I talked about your different deployment choices, I have something called a pricing tier. And in this particular case, I picked a general purpose with 2 vCores for this database. So I want to show you a little bit of a scaling scenario. I've got a client in the cloud, a virtual machine that I'm interacting with that Azure database. I've hooked these up connectivity-wise so that this VM and this set of Management Studio queries can actually talk to that VM. So I'm going to kick off a workload with OStress, just kind of like I did over there with VM scenario. I'm going to kick a workload off here using OStress, but this time I'm going to connect to that Azure SQL database that I've got deployed into the cloud itself. So I can go over here and I'm going to run a common DMV. You probably recognize this, DM exec requests. And I'm going to go take a look and run. I'm going to notice that in this particular case, I have a lot of queries that are in the runnable state with a weight of SOS scheduler yield. And so if you take a look at that, and if you've looked at SQL Server a while, that might give you a hint that a lot of runnable queries that are often runnable may mean that I'm a little bit out of CPU resources. Now, there's a couple ways I can kind of prove this. Number one, I can look at what I called resource stats. I told you about DMDB resource stats. So let me run a query on that. And you'll notice here, it's showing me a CPU percentage here of almost 100%. This is using the power of the cloud, where behind the scenes, we're tracking these resource stats for you because you don't have access to a perfmon on your VM. But I'm also even looking at weight stats here, and I notice here that SOS scheduler yield is a high weight going on for my workload. Now, if I go back and look at what I told you about the fact that I'm running general purpose, I can look at that through a DMV. This is the DM user DB resource governance, which is showing me some of my limits and kind of this, what we call a SLO or service level objective. That's another term we use for the fact that I'm running a general purpose Gen 5, it's something called a Gen 5 hardware. I'm running 2 vCores in this case. And so just kind of looking at this, it's possible that I may be out of CPU resource. It could be a bad query plan, but it could be the fact that the query plan's fine. I'm just only running on 2 vCores. Now, if I go and look at this particular query as it finishes and runs, I'll just kind of bring up the query itself to show you what it looks like. Let me bring that up over here. Yeah, this is going to use something against AdventureWorks, and it's not the best query, but it's not necessarily a bad query either. It does a lot of different columns that I'm pulling out from the table, but it seems like a real reasonable query, and these are pretty small tables. So it's not the fact that this query is really poor and needs a lot of actual tuning. It could be the fact that I just don't have a CPU resource. And in fact, if I look here, this finished in about 1 minute and 48 seconds. So let me go back over here and now use the power of the query store to see what the performance of the query looks like. So I'm using Management Studio, and this looks very much just like a SQL Server, right? I go into Query Store, I look at my top resource performing queries. This is that query, and I can see here by hovering over this that the average duration's about 22 milliseconds per query. Now you may be saying to yourself, well, so what? Is that a problem? But if you look at query weight statistics and hover over it, you'll notice that the highest weight resource is CPU. And in fact, if I click on here, I can see that my query was the query that weighted the most on CPU. The average wait time was 15 milliseconds out of the some 22 milliseconds this query was run. So now I can tell that without doing any tuning here, CPU could actually be a bottleneck for this query. So in order to see the results of trying to scale this query, I'm going to go first, I'm going to flush the query store here. I've got a query to do that. I'm going to manually flush my query store because I want to make sure I accurately see in my test here my query store results. And I'd like to bump up and scale my SQL Azure database. Well, how do you do that? Well, today in the SQL Server world, how do you scale a SQL Server with 2 CPUs to 8? Like, what do you do? Well, for a VM, you may have to shut the VM down and give it more vCores. What if enough vCores in that VM to give to that SQL Server? You may have to go and migrate your SQL to another whole machine altogether. Well, in Azure, it's very, very simple. So I'm going to go in and I'm going to run a T-SQL query to do this. This T-SQL query using Alter Database is going to move this with the same general purpose, but I'm going to use it to an 8-core model now. Now, this is an asynchronous operation, so Alter Database comes back immediately. But if I go back over to my portal over here, I will be able to see the fact that there's a scaling operation right here. It says online updating database pricing tier. So this is quickly moving me from a 2 vCore model to an 8 vCore model, allowing me to scale my operations. And if I look over here, I can see the fact that, in fact, this is so fast to move that it's probably already finished. If I go over here, I look now, in fact, this is not even here. It still says vCore, but if I go back over here to my VM, go back here, I'm going to go back and look at the service objective again, and I can tell I'm already now running 8 as my CPU limit. So if I ran 8 as my CPU limit, let's go over here now and kick off my workload again and see how fast it runs. Remember, it took like 1 minute 48 before. So let's go run the workload. Now, while this is running, let me show you a couple of things. Let's go look at SQL request again. Let's put that up here. This is just running dmexec requests. And I'll see here that while I'm running here, I've got more that are in the running state than runnable before. And if I look at resource stats, remember I had like 100% before, I'll bring that up. And now it looks more like 50%. Now, what I also wanted to show you while this is finishing here is to go back to the portal and look at the metrics for here. And if you'll notice, this is the chart I'm going to add. I'm going to use CPU percentage. I'm going to run it. And here is, let's go into like the last 30 minutes. We'll do it every 1 minute here. You can see I'm almost at 100%. So this is showing you the fact that we're integrating into Azure Monitor. What you saw in resource stats with DMV is integrated into the monitor itself. So let's go back over here and look at the workload and see if it's finished. And you'll notice over here, this workload now is in 38 seconds. So maybe there's even more room to scale, but let's go see what Query Store has to say about it. So let's go to top resource queries now. Now notice I have a different query ID. I had to recompile this query because SQL got shut down and restarted in this particular case. But notice how much faster it is to run this query. In fact, I can see the average duration in this particular case for 13, if I click on it, the average duration is like 7 milliseconds. Now, if I look at query weight statistics, you'll notice here that this query 13, the average wait for this query in CPU is less than a millisecond. So what have I done? I had a CPU-bound workload that really didn't have any query tuning opportunities. I realized I didn't have enough CPUs, and I simply, using a T-SQL command in a period of very short period of time, scaled my workload up to 8 CPUs very quickly. I should let you know that if you run that same workload in a serverless model, and if I had picked a min vCore of 2 and a max of 8, Azure SQL would have automatically scaled me to 8 without me having to manually do what I just did right there in that operation. So I'm showing you performance monitoring from a scaling scenario. You saw that DMVs can be the same with DM exec requests. We have new DMVs to look at resource stats and look at resource limits. And then also we've plugged into the Azure metrics model in the Azure portal through Azure Monitor. Okay, so as we get near the end of the presentation today, let's go over a couple other things. Number one, this is not a complete list, and you can expect people like myself and Elaine and Anna, as you see us more and more do events, presentations, workshops, you're going to see us add more and more content towards this space because we're trying to make sure as a SQL Server person, you understand what's same or different in Azure SQL. So there are some Azure specific scenarios I just want to point out. Number one, we do some transaction log governance in the cloud. Specifically, we have to do that to make sure we maintain the SLAs we promised to you for availability. You can look at some details about when we govern log type scenarios, but you'll see these things like log rate governor weights show up in wait stats that you've not seen in the past with SQL Server. For worker limits for Azure Database, we actually have worker limits built into the cloud versus seeing like thread pool weights. Whereas managed instance is going to feel like a SQL server. So you're going to have like worker thread maxes and thread pool weights in that scenario. And for business critical, whether it's a database or a managed instance, keep in mind, we're deploying availability groups behind the scenes for you. So hater weights are going to show up where you may not have expected it before. You're going to go to a business critical tier for Azure Database. I'll start running transaction scenarios. And even though maybe SQL's keeping up great, you're going to see a hater sync commit and you're like, I didn't set up an availability group. How did that happen? Well, we do that behind the scenes. So I just want to make sure you understand that you might see some hater weights show up that you were not used to seeing before because we are deploying availability groups for you in the cloud. And for hyperscale, there are some specific weights for hyperscale dealing with log rate throttling for different weight types. And you can look in our documentation for hyperscale diagnostics where we talk more about that. So our monitoring partners, and this is not all the monitoring partners that are out there, but these are the monitoring partners listed on the SQL Server monitoring site. And all of these, I checked on all of them. Every one of these you're used to know and love, all do Azure SQL monitoring. In addition, there's a plugin for Grafana. So if you like Grafana as a visualization, the Azure Monitor infrastructure has a plugin you can use to do Azure monitors with Grafana. Let me show you one thing though, as we're concluding here about the future of what we're doing. We're taking a look at the possibility of integrating the open source Telegraph software with our technologies with Azure Monitor. I want to show you a little bit what that looks like. So this is a possible view of the future. And this is just a mock-up of what we have. You can expect a much more rich experience as we're going through this. But notice as you look at these Azure SQL resources here, which could be a managed instance or a database, if you look at the top up here and click on activities, you'll start looking at charts that look very similar to what you're seeing or used to seeing, maybe in our Grafana or even an overall viewpoint of SQL counters. So you're going to see things like compilations, batch requests per second. Even if you wanted to go over and look at things like clerks or wait stats, things are going to show up and feel very familiar to you that you're used in the SQL Server world, whether it be IO, or maybe you'd like the ability to hook into any SQL Server performance counter that exists. So you click on SQL counters and you can see almost anything you can do in SQL Perfmon can show up in this insight. This is using a concept with log analytics and an idea called workbooks. And we're very excited that this could provide an even richer experience for you outside of what you might be doing through DMVs, through T-SQL, through other queries with SQL Server. And again, it's more about that integrated experience, providing things value add to you outside the scope of the database or the VM from an Azure Monitor perspective. Okay, we talked a lot today. We covered the fact that we kind of make sure we set the ground stroke for what is SQL Server compared to Azure SQL for performance. And make sure you keep in mind that a lot of the common things that you know love in SQL Server are there in Azure SQL. There's some differences, right? In some cases, there's a subset of what you're used to seeing, but most of what you need is there. And in some cases, there's new stuff. There's new DMVs or new extended events or Azure Monitor there to provide new experiences for you to help monitor your resources for performance scenarios in the cloud. And then, our monitoring partners are all there. Every one of them that supports SQL Server today supports Azure SQL. Wow, that was a lot of information, but I hope it gives you that foundation to think in terms of like, I'm thinking about moving to Azure SQL. I'm a SQL Server person today. I'm even worried that stuff that I'm used to doing isn't even there anymore. Well, you can see a lot of it is, and even more is there for you. So, Ree and Elaine, I know there's a lot of questions that came out there for us. Is there any remaining questions that Ree that are out there on the question that we have not answered?
So Anna and Elaine have answered almost every one of them. I think you probably touched on just about everything, but we had some questions about, is there a way to increase DTU for Azure SQL Database by using T-SQL or PowerShell rather than by using Azure Portal? And I think that that's maybe an answer that would be great for the rest of the attendees instead of just the person who asked it.
Yeah,
do I need to repeat it?
Yeah, no, it's a great question. And if you remember back in the demonstration I did back here, I actually used a alter database command right here this is an example of where I changed from a 2 vCore to an 8 vCore. And these options right here to change this service objective exist for everything you need to do. So, and that same functionality exists from AzCLI, from PowerShell, or from T-SQL. So all those interfaces are available for you to make any of those changes versus just using the portal.
And then one interesting question that just popped up: when scaling from 2 cores to say 64 cores, and if the capacity is not available, is there any VM migration that takes place to accomplish that, moving to 64 cores?
That's a great question. So we don't ever tell you behind the scenes, when you scale what we're doing, right? When I go to 2 to 8, it could be because of capacity we have. We just make a change right there. We just get to restart you and you're good to go, right? It's very, very possible for a very large change that we're going to have to actually move you to a different machine even, right? Or different SQL instance or whatever. They're very possible, those kind of type things. So scaling is never something that we give you automatic guarantees to say, oh, it's going to be these seconds or these seconds or these seconds. Obviously, the bigger scale you want to make, the more possibility it is that it's going to be a little longer to make that scale change for you, right? I have found typically when I make very small scale changes like I did here from 2 to 8, that's a very, very, very fast operation for us to do.
Right. So I think that wraps everything up today. Can you go forward a couple of slides, Bob?
You know what? Ree, for you, of course.
Oh, thank you. So one more. There we go. Coming up next, Hardware 301.
Look at me, I went too fast for you. Sorry.
Hardware 301, evaluating and choosing database hardware for SQL Server 2019. Glenn Berry is presenting that, and that starts in about 2 minutes. Thank you very much for attending today. You can always learn more from Bob Ward, always. There is a handout. If you look in your menu on the right, there's a handout that is his slide deck in PDF form, and that has the way for you to follow Bob Ward to the slide deck that he talked about, to SQL workshops, all of that stuff. It's all there. So go find it, go attend Glenn Berry's session. And before Eric ends the meeting for all of us, I wanted to say happy birthday to Anna. So if you follow her on Twitter, make sure that you say happy birthday to her.
Yeah, nice. Thanks, Ree and Elaine. Thanks for everybody attending today.